Unit 1, Lesson 4, word problem number 3. Always start by resetting your calculator. When you do it correctly, it's going to say RAM cleared. Let's get started. The population of Vice City from 1995 to 2003 is given by the following table. Now, what you're not going to see on any practice assessment is I'm not going to give you this information. You have to remember that time is always going to be your X value. And in this case, your Y value is going to be the population. Now, that population is in millions. So our initial year is 1995. So in the year 1995, we can assume the population of Vice City is 1.39 million. This represents 1 year from the initial, 2 years from the initial, 3 years from the initial, and so on. Again, this information, you have to understand that time is always your X. And this is why I believe this problem may throw students off. It's natural. You see the top one, we assume that's the X values, and we assume the bottom values would be the Y. In this problem, they're testing you to see if you understand that X's will go with time. All right, it tells us to use a cubic regression model. So what I'm going to do right now is I'm going to come up here and I want to go to statistics and I want to press edit. Now, L1 is always going to be your X value. So I'm doing 0 through 8. It's really easy to make a small mistake here as you plug it in, pressing enter each time, then using the arrow. And I'm going to slow it down here, 1.39, 211, 252, making sure I'm correctly plugging this in, 251, 02, okay, so I've plugged it in. I am going back to check. I often make really small mistakes when I rush through. Looks good. So it tells me what type of regression model. Remember, a regression model is going to take the data points and it's going to make something that models them. So it doesn't mean that every single point along here will go through the model or the line of the graph. Let's take a look what this looks like. So my X's are going from 0 to 8. So let's come up here and let's go a little bit past it. Let's go like 0 to 12, somewhere past that. And if we go and hit second and scatter plot, we can turn on the scatter plot by pressing enter twice and then hitting graph. And so now we can see those points. Now, how do we actually come up with an equation of a function that models these points? Remember, just because it models it doesn't mean it's like connect the dots. Does not mean that. Okay, so what I'm going to do right now is I'm going to turn that back off so it does not confuse anybody. I'm going to do second scatter plot, pressing enter. I got to move it over and pressing enter. And now I want to go up to y equals. There's no function in there right now, but I'll show you how we can take an equation that models those dots and place it here. Let's go back to stat. Move over to calculate and go down to cubic regression. How do I know that? It says use the cubic regression model. And then we're going to press enter all the way through. Just keep pressing enter. And there's our equation. Now, just like if we were in a Word document on your computer and we use the copy and paste feature, we're going to do the same type of thing on our calculator. Come up to y equals, and please go to vars. Now go down to statistics, go across to EQ, and press enter. We just copied and pasted that information. And now when you hit graph, this function models the data point. So it's going to be an approximation of the population of Vice City from 1995 to 2003 based on those data points. An approximation doesn't mean it's a guarantee. Let's get started. Graph it, and then we want to have an appropriate window. So appropriate window means we understand that if Y's represent the population, there's no negative population. So I can come up here and I don't need to have those negative numbers. We also need to recognize that our Y values are in millions. So when you go ahead and you come over and you graph this function, I went from 0 to 12. So I would write 0 to 12 after I draw the picture. And then I went from 0 to 10. But remember, it's 0 to 10 million. So off the side, I may write 0 to 10 for the Y minimum and maximum, but I'm going to write in millions. So I understand the population is in millions. Let's get started. How high did the population get? That means what is the maximum Y or the relative maximum before it dropped off? Let's take a picture of this here. So how high did it get before it drops off? I want to know what is this point. Second trace, to find that relative maximum, we're going to take the arrows. And I want to go slightly to the left of the highest point. and slightly to the right of the highest point. And then I want to guess where is that high point. Okay, so how high did it get? Sometimes students say, okay, I found the point, but which one is the correct answer? The correct answer, how high did the population? This is population and this is time. So this is the population, but now I need to turn it into millions. If you took this value times 1 million, it would be taking this and moving it to the right 6 places because a million has 6 zeros. So if I move this to the right 6, 1, 2, 3, 4, 5, 6, I'm going to cover up the 9. 2,536,851. That's what we can assume the population is at this height before it drops off. How low did the population get before the city rejuvenates? So I want to know what is its relative minimum, second trace and minimum. And the same concepts, I'm going to follow the direction going to the left bound. So left of the lowest point, press enter. Coming over, we're going to go to the right of the lowest point, pressing enter, and back down to the lowest point. Again, I'm taking this value, we're talking about population, taking it times a million. So I move it to the right 6 places, which would be covering up the last number. So we can assume before the city began to rejuvenate, there would be 1,304,108 people living in the city. According to this model, what was the population in 2002? Now, here's the mistake a lot of students are going to make. They're going to go second trace and they're going to go 2002. But remember, we have renumbered this. 0 represents the year 1995. So here's 95, 96, 97, 98, 99, 2000, 2001. Here is 2002. Here's 2002. But it says according to the model. So I can't just say 1.48 million. It wants it based on the model, not based on the data point. So this is year 7, according to my model, second trace, value 7. And if I move in here, I'm going to move it 6 places to the right. 1, 2, 3, 4, 5, 6. So in the year 2002, according to the model, we can assume there'd be 1,441,767 people living in the city.